Hi everyone, thanks for coming. I'm Flavio. I work at Shopify as an Android developer, and today I'm here to talk about expressive asynchronous code using coroutines. This is not a deep dive into coroutines, so if you're not familiar with coroutines, that's not a problem. If you know a bit of it, that's great. But the main thing that we'll be exploring here is more of the principle of converting asynchronous APIs into synchronous ones, and coroutines is going to be the tool for that. Okay, so this is a method that I have written several times in my life. I've been doing Android for some time, and I believe that all you guys have written something like that. So we have a function, make async call, and then we create some sort of API class. Not a REST API, but think of that as any kind of API. It could be maybe a Twitter client or any class that exposes methods that are asynchronous. In this case, we call do something async. We pass lambda to it, and then that do something async method will do something probably in background, some long-running operation, and then the result will be delivered to that callback. Sometimes we have to do something like that. So we run that background method, like that asynchronous API, and then the result is delivered to a worker thread or to a thread that you don't know, and you want to do something useful. So you have to switch to the main thread and then maybe show something in the UI, touch the UI, because you don't want to get an exception because you're touching the UI in the wrong thread. So that adds some complexity to the code, and that's the question I usually ask. Why APIs are designed like this? There are many APIs that are designed to be async in first place. And the answer for it is that mostly APIs are designed like this to prevent blocking the main thread. It is not always true, but this is something that depends mostly on your audience. So say you're developing a library, or maybe you're just Google and you have a set of APIs that you have a lot of different developers of all sorts of skill set and experience. You don't want beginners to mess up by calling things on the main thread. That's pretty that's a big problem, and you just want to make easy for them. Not everybody has a background on concurrent development, and this can be the easy way to have people get started on Android development or on your library. There are a couple of APIs on the Android framework that are designed like this. So for instance, if you've ever had to develop an app that needs to grab the user location, you're going to have to make an async call, and then you get the user location delivered to a method, to a callback. If you've ever had to develop an app that involves media playback, maybe like a sound or a video, there might be a complex state machine that has to be initialized, that there's a callback that you have to listen to, and you have to deal with those kind of async API problems. If you've ever written an app that involves Bluetooth devices, like connecting to those, consuming whatever those devices offer, like say a heart rate monitor, like if you want to read things like your heart rate, or maybe earphones, you're gonna have to deal with asynchronous APIs to connect to the device and to use it. And also several third-party libraries. Sometimes we have to integrate our app with a library developed by a company that provides a service that we need to use, and those libraries are developed in an async way, so it exposes a bunch of asynchronous methods. So I'm not saying that asynchronous APIs are bad for everything. Sometimes it makes sense. Like I said, if you want to make your life simpler for beginners, if you want to protect the main thread, but sometimes your code can get quite complicated if you have to all the time run an asynchronous method, especially when you have to chain several asynchronous methods. Like in one callback that provides the result for your asynchronous method call, you have to call another asynchronous method that which in turn will be delivered, have its result delivered to another callback, and so on. So let's exercise a bit complex scenario using the Bluetooth Low Energy API on Android. I'm not sure how familiar you all are with that, but let me just make a quick introduction to how Bluetooth Low Energy works. So first we have the GAT server, which is pretty much the device we want to connect to, say a headphone or heart rate monitor or whatever. It's a server because it provides services, things that you can consume. So like a heart rate monitor, you can like get readings of your heart rate. So a server exposes a bunch of services. A services is pretty much a set of characteristics. Characteristics are just attributes. So for example, in a heart rate monitor, we can have a service called heart rate and two characteristics. One is the heart rate value, which is actually your heart rate that's being measured, and something like heart rate monitor position, whether it's a chest heart rate monitor or it's a wristband. And a GAT server can have multiple services, and each service can have multiple characteristics. Okay, so let's think about some generic device that is battery powered. It can be any Bluetooth device, mostly. And it exposes a service called battery service. And we have the battery level, which is what we're interested in. So let's exercise, now that I went through all those details about BLE, let's exercise a use case that I have to implement once. And it's something that can be ported to other problems that have an async nature. So let's say that we want to scan for Bluetooth devices. This is an asynchronous call. And then we want to connect to a specific device we're looking for. So say we're looking for a device with the name X or a specific MAC address. Somehow we want to filter the devices we find, and then we choose one to connect to. When we ask to connect to that device, that's also an asynchronous call, will be delivered to a callback, the device, the connection attempt status. And then we want, after we connect to it, we can discover services. So now that I'm connected to, say, a heart rate monitor, what are the services that you provide that I can interact with? This is also an asynchronous call. And then after you get the result of the services that that device provides, we want to read one of those characteristics. It's also an asynchronous call. So here we have 4 asynchronous calls, and they are all chained. So let's see how it works in code. We have here a Bluetooth adapter, which is the class defined in the Android framework. That's what we use to deal with BLE. So let's say we come up with a method called discover device. We call start scan, which is a method that we can see over there. It takes a callback. That's our very first asynchronous call. We're using an asynchronous API, which is the Bluetooth Low Energy API on Android, and we're passing a callback. The result of that search will be delivered to that callback that we're going to define right now. So here we declare the callback. We have to override this method on scan result that's going to be called every time a device is detected around you, around your phone. Here we check, like we did some filtering. So let's say we're looking for the device called my battery powered BLE device. And then once we find it, we want to stop scan. There's no reason to keep scanning because we found what we were looking for. We don't want to waste battery. And then we decide to start a connection here with that specific device. As can be seen here, that's also an asynchronous call. And we're passing a callback here. The GAT itself that we get as a response to that connect GAT can be seen something like a connection class. This is a Bluetooth connection that you'll be interacting with to do whatever you need in regards to that Bluetooth device. So we get that connection object return from connect get, but that doesn't mean we're connected. So the callback, let's define the callback that will detect the connection result. We have to override on connection state change. Here we check if that connect request was successful and if the device is connected. At this point, we have to discover services, right? Because we want to know what services can be consumed from that device. So this is the call. We call that on the get, as we can see here. This is an asynchronous call, too. The callback is defined in the same callback class that we're defining that we can see here. So that Bluetooth GAT callback extension. So here we no longer need this method. Let's collapse it, and then let's override on services discovered. This is the method that's going to be called in response to discover services. At this point, we check status too, just like we did in onConnect states change, and then we grab the services that now they have been discovered, so they're available. We're going to filter them, and because we're looking for a specific service, there might be more than one. We're looking specifically for the battery service, so we filter it. Then we'll list all the characteristics. So here we have an array of all the characteristics that server provides. But those characteristics are pretty much metadata. You have an ID for every characteristics, but you can't read the value of them. They are not available yet. We have to discover those. So let's filter those characteristics to find the one we're looking for, which is the battery level characteristic. So we find it, and then once we grab hold of it, we call read characteristic. So that's gonna send a message from your phone to the device over the air, and then of course this is also an async call. The callback also is the same one, so let's collapse on service discovered here and define a new method called on characteristic read. This is a method that will deliver the actual value of your characteristic. Well, not really. It will notify you that it's ready. You can just grab it from the GAT. So here we do the same thing. We check the status if our request to read that characteristic went through. Now we can read the characteristic.value property in the characteristic object. Before we couldn't do this because it was null. Now that we have explicitly asked the Bluetooth device how to read that characteristic, we can have a chance to read that value. So that's going to be a byte array. We convert that to big integer to have something between 0 and 100. And then we can, after all this whole crazy callback chaining, we can do something useful with that. Right now, what I'm doing is just logging. But say you want to show that on your UI. So to recap, this is all the dynamics of the communication between our app and the Android framework and the Bluetooth stack and the actual device, Bluetooth device you're talking to. So first the app starts scanning. That's an asynchronous call. It takes a while running until it finds a device, and then this callback is called on scan result that will deliver to you all the devices that you found. Actually, it's going to be one call for every time it finds a device around you. So once you find the device you're looking for, you filter it, and then you want to connect to it. So you issue a request to the Android framework to connect to that device. Also async, takes some time to run. You get that response delivered as a callback. And then same thing for discover services, async, get a response in a callback. And then you read characteristic and get an async response. So here we have four chained calls. That means the next call needs to wait for the previous one to complete to get its result delivered so that it can be executed. There is a dependency of data, and of the execution flow depends on all those callbacks to be called. So some concerns that we need to consider, things like what thread are these requests running on? So whenever you call one of those asynchronous methods, should this call be done on the main thread, or can you offload that to a background thread? Will there be any issues if you don't? So this is the thing to think of. What thread are these callbacks running on? So you call something asynchronous, you get a callback called, and you don't know what thread that callback is being delivered. It might be the main thread, it might be a worker thread. You might have to switch the main thread using some sort of run on UI thread, like I showed in the second slide. Is all this thread switching really needed? Do we actually need multiple threads and switching from one thread to another to accomplish something that could be simpler? And what if I'm already on a background thread? So for that exercise that I just showed, like discovering Bluetooth devices, connecting to it, discovering services, reading the characteristics, why is it so callback heavy if I could just spawn a thread and make all those calls in a synchronous way? So my takeaway about that after working with some heavily async APIs is that async APIs aren't nice. Again, this is not always true. It depends on who you are developing those APIs to. If there are a bunch of beginners, like people from all backgrounds that are learning Android or sometimes even learning how to program, you want them to be easy. Sometimes you have a very simple code base that you have APIs that you just call it, it delivers a result and that's it. Sometimes you have asynchronous APIs that are always producing results. They're always emitting new elements to that callback. So it depends, but I have seen several times APIs that were designed to be asynchronous that when you have to do something a bit more complex, it gets in the way. So why do I think that async APIs sometimes are not nice? That might be a bit opinionated, but that's what I think. So async APIs make assumptions about the client's execution requirements. So the developer of that API is assuming that that API will be called on the main thread, for instance, and they are trying to protect the client. They can be less expressive. There might be a very complicated statement flow, like a go-to, just like I showed on the Bluetooth example. If you're trying to do something a bit more complex, it's hard to follow. You might feel the temptation of coupling business logic with execution logic. So think of that first API that I mentioned in the beginning, that async class, whatever, that had a single asynchronous method. If you're writing that class, you might feel tempted to not only add all the business logic that your code needs to do, like the things that really matter in the problem you're solving, but you might feel tempted also to add a bunch of things related to threading. So maybe executors, handler threads, thread pools, spawning new threads. And threading is usually something that's orthogonal to the problem that you're trying to solve, right? It's like a cross-cutting concern. So maybe you don't want to mix those things. You don't have to, but you might feel tempted to do that because you're developing an asynchronous API. Asynchronous APIs sometimes are hard to mock. So if you're using Mockito, like most people do, I believe, and you have a dependency that is an asynchronous API, an asynchronous class, and when you want to mock that asynchronous method call, you have to do something like when, method call, then answer, and then in your answer you have to grab an instance of the argument passed to that call, which is a lambda or a callback, and then explicitly call that. That's going to make your test a little bit confusing and harder to read, so you don't want to abuse that. Whereas if you have a blocking API method that you call and then it just returns whatever it does, you can easily mock that by calling when, method call, then return, so we can get cleaner tests. It might be harder to debug because you don't understand very well the execution flow. And it might be harder to handle errors because in that example, Bluetooth example, what if something happens during the service discovery or reading a characteristic? You have several points of failure because you have multiple callback based method calls that can go wrong, and you have to somehow bubble up to the client. You could use maybe RxJava to work on that and fix that. But for that, we're going to use coroutines. We can go on that later. And asynchronism is overly fine-grained. So there's something that I call fine-grained execution flow. I don't know if there's a name for that, but that's how I call it. It's something like that. So you have, say, the current thread, and then you want to perform some task, and you're using an asynchronous library or API or class, whatever. And then you make a method call. It's going to perform a single task, say, connecting to a device. And then after that, it will deliver that result to you, maybe on another thread that's different from the one that you called, or maybe it's going to deliver to the one you called. And then you want to make another call right after task 1 is fully completed. You're switching context again, and then you run that call, and then it goes back to another thread, and then you do it all over, and it feels like the library or the asynchronous API, whatever you want to call it, is making the decisions for you in terms of what is the grain size of the tasks to be done. So if you have to run several tasks one after another, it makes your life a bit harder. And what I call coarse grain execution flow is something that you can achieve using some sort of blocking API. So you have current thread, you want to execute a sequence of tasks, so you can do something like that. You offload that to a background thread, you run the task 1, and then task 2, and then task 3, and only after you're done with all these tasks, you can just return the result or switch back to the main thread. So this is the kind of thing that we're trying to achieve that, and I'm going over that using coroutines. So I'll take that Bluetooth use case and convert that to something that is more synchronous using coroutines. You don't have to use coroutines to do that, though. You could use that. You could use something like RxJava that could be maybe helpful. You could use plain old threads and concurrency classes from Java, like countdown latches or blocking queues or threads. But if you're writing something brand new from scratch, you probably want to use coroutines because that can make your life easier for several reasons. So here's what we want to achieve. So we have our app, the Android framework, and we want to do something like that. I want to call Bluetooth LE scanner .scan .first. So this scan call will return some sort of pipeline or event bus or event producer. If you're used to RxJava, think of that as an observable. If you're familiar with coroutines, that's going to be a flow. So anyway, it's something that's going to produce events. And you want to grab the first event, and you want that whole statement to be blocking. That's going to return you a device that is ready for you to work with. So that call is blocking. It returns a device. And then now that you have a device, you can call device connect, which is also blocking. And then you get a result that's going to be true if the connection was successful, false if not. After that, you can safely call discover services, and then you get a list of services, also blocking. And then read characteristic, you get an updated characteristic that you can use right away. So we can make the code a lot more linear by using this approach. And I'm going over the API implementation using coroutines for that. So the whole idea is to wrap all those Bluetooth classes provided by the Android framework into something that can be called that way. Instead of passing callbacks, you just expect your wrapped APIs to return types, to return results instead. So we come up with a suspendable Bluetooth LE scanner, which is going to wrap the Bluetooth LE scanner that is asynchronous. So here we create a public method called scan that's going to create a callback flow, so think of that again, if you're not used to coroutines, think of that as an event producer that can be later on subscribed by whoever calls scan. So here we define the scan callback, which is the callback that we used in the previous example when we were using asynchronous APIs only. And here we have to override on scan result. So here in the previous example, once we found a device, we were actually connecting to it. Right now, we're not doing that. We're just emitting an event into that flow. So we're like pushing down the pipe a suspendable Bluetooth device. This is the wrapper around the Bluetooth device itself. That I'll go into that later. And it's closed for send. It means if there's nobody watching that flow, that this scan method returns. So there's no subscribers to it. Nobody cares about the events being produced. Just don't offer anything because it doesn't matter. So now that we have the callback all set up, it's time to start scanning and then plugging that callback into the Android framework, the BLE stack. So we call start scan. We pass in that callback that will convert the results into items being emitted by that flow. And then here what we do is we stop scan once that flow is not being subscribed anymore. So if somebody just closed a subscription to that flow, nobody cares about those events, then it just stops scan because you don't want to waste battery, right? So now that we have converted the scanner, we can now we have that big callback that I showed earlier that had all those three methods: on connected state change, on services discovered, on characteristics read. So all those three callbacks, we're going to convert that into a class that will expose also a pipeline of events. So we want to convert something that's callback-based into something that's event-based. So we're going to implement that. So this is the wrapper around that callback. We just define a callback here. Here we define the pipeline of events. This is a Coroutines channel if you're familiar with that. If you know RxJava but doesn't know Coroutines, think about that as an observable or maybe a subject. So here we just open a subscription on that channel whenever somebody reads that property, and here we implement on connection state change. In the async API, we were here in this method discovering services. Here we don't want to do that. We just want to convert this call into an event emission. So we just check if the request to connect to that device was successful. If so, we just push an event down the channel. Somebody will be notified, whoever is subscribing to that event channel. If not, we just push down the pipe an error. So let's collapse this. We no longer need this. Now we have to do the same thing for on services discovered. So here, again, in the previous example, using async APIs, we were here requesting to read a characteristic. Here, we just want to convert that to an event. So we check here the same thing, status, if the request to discover services was successful. If so, we push an on services discovered event down the channel. If not, we just push an error. Let's collapse that too, and then we have to do exactly the same thing for on characteristic read. So here we check for success, and then we offer on characteristic read event, wrapping the characteristic. Otherwise, we just send an error. Okay, so let's get back here to the context of the suspendable Bluetooth. So let's go over we haven't seen this yet. The suspendable Bluetooth device. This is actually the device we're going to be interacting with instead of the Bluetooth LE device that Android provides. So here we have the connection, the GET object, which is more like the connection, and then the callback that we just defined here in the previous slide, right? So coroutine GET callback, we have it here because we have to plug that in the GET object once we connect. So here, this is the public method that we want our clients to call. Notice that it returns a Boolean. true if successful, the connection successful, false otherwise. And here's what we do. So let's clean things up here. So here we start consuming all the events produced by that wrapped callback. We no longer want those callbacks. We just want to consume events in a streamlined way. You can just subscribe to that and check what the event type is. You don't have one callback per event type. And here we trigger the request to connect to the device. So that means your phone is actually trying over the air to connect to your Bluetooth device, and we pass in the callback that we just defined, right? So that callback, when it gets called, is going to produce an event with a response for that connect get call. And here we want to wait for that event and block, not really block, it's actually suspend. If you're familiar with Coroutines, again, suspend and blocking, it's not quite the same thing. But if you're not familiar with Coroutines, think of suspending like blocking. It means that that method call will not move over from that until that method call returns. So here, this call will be blocking. So what it does here is it maps the event channel in a way that if the event that was generated by that callback and pushed down the channel that we're subscribing to, if it's on connect state change, which is the one we care about, we return true if it's connected, false otherwise. If we get an error, it's also false. If you get any other event, we return null. This is not going to happen because you're not getting any other event for connect get. But we want to satisfy the when clause that has to be exhaustive. And here we filter not null to make this whole object here non-nullable, right? And then we grab the first. So this first call, this will subscribe internally to the channel, to the transform channel by that map call, and then we'll suspend, or it will block. And then until we get an event that satisfies those conditions defined in the map, that transformation, then we get blocked here, and once we get that, we return connect with either true or false, depending on what we get. So let's collapse that. Let's get back to the scope of suspendable Bluetooth device. This is a public method. Let's create now another public method, discover services. Now we use the GET connection that we're expecting the client probably has called connect. If it's null, it means that it's not connected yet, so we're returning an empty list of services. If they're connected, GET will not be null, and here we do the same thing. So we create a subscription, and then we trigger the discover services call over there, and then we wait for a specific event, then we grab the first event, that means the response for that call, and then we grab the list of services that that event exposes. And we return that, so that means that discover services will return a list of services. So let's collapse that, and let's do the same thing like a public method to read a characteristic. So let's clean this up. We do exactly the same thing here, right? Waiting for the first event of a certain type. Now this type will be uncharacteristic read. Okay, so here we are. We have a wrapped synchronous suspendable Bluetooth device that uses coroutines, and let's see how the final API looks like from the client perspective, how you use that instead of that callback chaining. So we create a suspendable Bluetooth LE scanner that we just wrote that wraps all that complexity. And here we grab a Bluetooth device, so we call scan.first that will block until we get a device. Maybe this first method could take a predicate or a lambda with a predicate, so we could specify what are the roles to define what is the scan device, what the Bluetooth device we're looking for. So here, now that we grabbed a Bluetooth device that was found, we can connect to it. So if connect returns true, that means the connect went through and we're now connected to it. We can do something useful with that device. Here we can discover services that will return a list of services. Then a battery service, we can look in that services list for the very first service of a certain UUID. Now we're looking for the battery service because we're interested in getting the battery level of that device, right? After we get that service, we can look for a specific characteristic in that service. Remember, a service is basically a list of characteristics, and characteristics are just properties. So we're looking for the battery level characteristic here. Now that we have the characteristic, we can read its value, because at first we only had the instance. Now we have the characteristic. So we can call read characteristic on the Bluetooth device. This is wrapping an asynchronous call. We're going to get the battery level in response, and then we can do something useful finally with the battery level. In this case, I'm just logging it. And if connect is false, we just log it. We could do something more useful than that too. And here is the whole code that does all that thing. It's a lot easier to understand and to follow. Please note that here I'm just handling errors for connect. We should be doing the same thing for discovered services. That is something that can fail because it involves sending a message to the device and getting a response back. Same thing for read characteristic. We could just either throw an exception if something goes wrong, or maybe wrap, instead of returning maybe a list of services or a characteristic, we can just wrap those returns types in some sort of result class that will have some sort of indicator whether that request was successful or not. But I wanted to keep things simple. We'll probably just add 2 more if statements here to have full error handling. And the whole takeaway of this approach and the idea of converting asynchronous APIs into synchronous APIs is that async APIs sometimes can be confusing and hard to follow because you have a lot of callback chaining. This is really complicated. Sometimes you write a super long class with a bunch of state tracking variables. You probably don't want to touch that class because you're afraid of breaking something. So you also want to avoid making assumptions about the execution requirements of your clients. So this thing that the client needs to be on the main thread, or assuming that the client will want to call your method on the main thread, might be a problem sometimes, because maybe they want to perform that action in a background thread, or it's already in a background thread. They don't want the user to see that, and that having an async API will not help with that. So depending on the team, depending on how much familiar your API users are with threading and Android development, maybe you can make things simpler if you go with a synchronous API and leave it up to the caller to control everything related to execution and thread scheduling and all these things that are cross-cutting. Code should be linear like a recipe for better expressiveness. So this is something that I truly believe. To me, code should like a recipe. If I'm making a cake, I have a recipe on my hand. I want to follow one instruction after another. I don't want to be jumping, skipping instructions, and then going up for previous instructions and following a crazy path to get things done. I want to read it from the beginning to the end. And that's, in my opinion, is the best way to express intentions. And code, every code tells a story. You want that to express intentions the best way possible. Coroutines can help clean up callback-heavy APIs. Again, you don't have to use coroutines. People can be very successful cleaning up callback-heavy APIs using RxJava. If you're using that, you don't need to switch over to coroutines unless you have a big reason to. You can do the same thing using threads, like I said, using the concurrency toolkit provided by the language. But if you're starting something new, you can use coroutines because it might make your life easier for several reasons. With coroutines, you get better performance, you get scoped concurrency, which are things that I'm not going through today. But that's pretty much it. I hope that's valuable. If any of you have any questions or want to disagree with anything that I said or want to discuss that further, that's it.
raise your hand if you. Okay.
What's the difference between suspend and block?
Okay, so suspend and block. When I say that a thread is blocked, it means that the thread is completely idle. It's not doing anything. It's waiting on something, and once that something ends and gets completed, it will return back to execution. When we say that something is suspendable, it's funny because coroutines are super powerful, and when you have a coroutine doing some work and then it encounters something that is suspendable, say call to delay, there's like delay 1 second. So that means when the coroutine sees that suspendable function that is not doing anything, the coroutine will say, okay, now I'm idle, I'm going to free up the thread so that another coroutine can run. So a thread can have multiple coroutines running at the same time. Not really at the same time, because it's still a thread. So you can have multiple coroutines that are like active, one running at a time on that thread. And then when it finds something that is it is suspendable, either because you created a function that's suspendable or something that just hangs because there's nothing to do, it just uses the idle time of the thread to switch to a different coroutine and get something done. It takes a bit to figure that out. At least it took a bit for me. Well, I hope that answers your question. I don't know.
I guess I have to try and.
Yeah, you should.
Yeah.
What's the difference between? Is it a mic? Oh, okay. What's the difference between flow and channel?
Okay, so yeah, at first they seem to be the pretty much the same thing. The thing is, the flow is something that is cold, so it starts emitting items when it's created. So you saw that callback flow. So when that lambda runs, that's the time that it starts producing stuff. A channel is more useful when you have some sort of hot flow. So think of something like user touch, like user sliding the finger on the screen. The user is producing those events no matter if somebody's watching or not. So maybe it's valuable to use a channel for that. For those used to RxJava, the best definition will be flows are cold emitters and channels are hot emitters. There's also a difference though. Flow has a bunch of operators that you can transform the whole pipe of events. Just like RxJava, you have things like filter, map, flat map, first, a bunch of all those things. Channels used to have those operators. Right now, they're all deprecated. So what you have to do if you want to use them, you have to convert your channel to a flow. There's a method, a helper method to do that, and then you apply all those operators by consuming your channel as a flow. Sometimes it's kind of a gray area to define if you should choose one over the other, at least for me. Sometimes there are situations that both could do it. But yeah, it's pretty much it, I would say.
Thanks.